Welcome back, guys. So today we are going to create an e-commerce chatbot that can handle all type of queries from your customer. So today I'm going to focus on the thought process rather than the code. Let's say you have a customer on your e-commerce store. So what kind of queries he would ask? Let's say assume he asks these type of queries. Hi, I need to check the status of my order. I want to return the wireless headphones. I am very disappointed with the recent purchase. Can you track my package, or can you refund my package? So these type of queries are very common. Pretty much all e-commerce stores face these problems. So what we can do is start by creating a LangGraph state graph, and then add in LLM AI based tools to get the query to its completion. First of all of the code is in the Git repo. You can check it out in the description. I'll add the link. So the prerequisites for this code project will be the GPT calls. So we'll be calling GPT API, and you have to learn the basics of LangGraph. You can check out my previous video for that. You have to know how the graphs work and how the nodes are connected with conditional edges, and that is it. That will take you about half an hour to learn. So you can continue after that. Let's start from here. So let's continue with the graph. Actually, I've created this state graph. You must know the nodes and edges, the concept of nodes and edges, that conditional edges or start and end nodes. So what I'm going to do is explain from the start node. So the customer opens your website or your app, and then the customer has to input some kind of query to the chatbot. Let's say he asks where is my order, or track my order this. So what we can do is we can start the graph from start, and the first edge will be here with the classify query. So what we can do is use GPT to classify the query of the user. So if it's a return query, or it's a complaint query, or it's about handling the order or extra special request, you can use GPT to classify it into different categories and then move on to the next node. Let's say order handler, return handler, or complaint handler. Or if it's out of the scope for all of these, then you can just create a general response, generic response from GPT, and you can end the conversation right there. But if it's a order handler, let's say, or a return handler, so what you can do is make a function, and you can fetch the details of the order of the user, and you can using your DB calls, database calls, or another third-party API calls. What you can do is create a return request, and then go back to general response for the user. And if he wants to track it again, you can go back to the classify query and run the graph will keep on going until and unless the user opts out. So rather than the picture, let's go to the code and start creating this graph from scratch. Let me explain this. This is the code for creating the state graph. So we initialize the workflow object of the state graph. This is LangGraph class, so use this. You can do it manually too, but we are learning LangGraph, so we'll be using its inbuilt functions and classes. How to add nodes? So we will have 5 nodes. Start and end are inbuilt nodes. We don't need to create those. We just need to create these 5: this classify, order, return, complaint, and general. So what we can do is add these nodes and attach a function to each of these nodes. So whenever your code reaches this node, this function is executed. So we'll get back to the definition of functions later. Let's just create the graph first. So we have added 5 nodes. We have created these. None of these are connected as of now. Now we have to start from the start node, and we add the edge from start to classify query. So this is the edge, that is first edge from start to classify query. And now what we do is add conditional edges. So I've already explained this before. Conditional edges just takes a source node and it takes a condition. This will return the string for the next step. So if the next step is order handler, then go to this function, go to this node. If it's return handler, then go to the return node. Complaint handler, then go to complaint node. If it's response generator, then go to generate response node. So this is the condition and this is the source node. So we have 4 conditional edges from here. These 4 are represented by these: order handler, the return handler, the complaint handler, and generating the response. Right, these 4 edges are conditional. So now what we do is, from those 3 nodes, order, return, and complaint, we create conditional edges to either end the conversation, so user has opted out of the conversation or he doesn't want to continue, or you can generate a generic response, and you can keep the conversation going back to the classify after that. But for now, we'll just these three nodes will each will have two conditional edges and same conditional function. So this function returns response generator, so the next node will be generate response, or if it returns end, then just end the conversation. Same for these two. So these will be represented by these. So one is going to end and one is going to generate response. One is going to end, another generate response, one is to end, and the other generate response. Now, and the final edge is simply from generate response to end. This is a single edge. This one, this will be represented just to end the conversation. So we have created our graph, and we just compile the graph, so it can be used easily in the next function. Now we can move on to the database. So for now, you can add your actual database, but I'm using a simple JSON based database for dummy database, right? Because that will complicate the code for now. I'm just using this JSON objects, and then I'll be parsing these to a Python object, and then using the data that will simulate our API calls, right? So for our database, we have orders. These could be your tables, using these as primary keys, but for now, just simple objects will do. So let's say we have customers database. We have two customers, customer 1 and 2, and their details and their orders, multiple orders. So it's an array, and each order will have its own details. So this will be a table in itself, and this will be the primary key that connect your table to the customer table. And then you have the details of the certain order and items as well. Items could be multiple in one order, and the cost, right? And this is simple return policy. So cost will be 10% extra, restocking fee, and the return window is 30 days, blah blah blah. You have just simple three objects for database I'll be using, nothing too complex. And obviously the database will also need your tools. So to simulate the API calls to database, we can define tools and use these functions directly. So this is for lookup order. Let's say it just gets the order from the JSON, and if it's order present, then return back the order, or if it's not present, then return the error, right? And lookup customer, check if customer is available for that ID or not, else return the error. Track shipment, so this function just simulates the tracking information. This is a dummy object for tracking. You can create lots of functions to simulate your API calls. These are nothing special. Initiate return, so this will just generate an initiate object and create a request for it. You can create a DB call and for given order ID, and you will have your own return request for that customer. You can process refund. You can check return eligibility if the customer is present and order is valid. You can check how long it has been that customer has ordered that product, and if it's under the refund policy, then you can check for eligibility and return the response, right? And if it's not covered by any of these cases, then you can just simply escalate it to human and assign a operator. This is how it's done in the real world. So some operator will obviously be assigned to these tasks. And now we have our agent nodes. So we have created 5 nodes, and each will have their own function to run. So these 5 functions will be defined here. So let's say we start from the query classifier. So what happens is you have a state. I think I've already explained state. State will keep all the variables of the graph and will be shared by all the nodes. So we have a state. We get the customer query. So this is the customer query that user asks, basically user input. So you extract the order ID if present in the message. So let's say customer says I have this order 1 2 3 4 5 and I want a return for this. So you extract the order ID and save it in the order ID variable, right? Nothing, just using a regex pattern to find the order. Then what we do is use GPT to classify the query and to classify the sentiment of the query. So let's say the query is not that important for now, so we can keep the priority low. And if the priority is if it's like the user is very angry, then you can keep the priority very high and escalate it to humans, right? So this is just a classification prompt, simple. This is the same prompt that you would write in ChatGPT web UI. So just take some message, system message. I've already explained what system prompts are. This will set up the background for what kind of content to generate for the LLM. And human message, this will be the user prompt. So this is the template for this that I've created that determine this sentiment for the query, for the user query, and its priority. And here I'll be adding the query from the customer and respond back in a JSON format. So we'll be using JSON format because it helps you get to more definitive answers rather than general answers. So you can use this with Python code, just dump it into a Python object, and then we can use it easily. These categories, type, priority, etc., these variables, right? So what we can do is we can get the response back from LLM, and then we try to classify from the JSON that it returns. We classify the query type, we classify sentiment and priority, and then we change the current step of the state to query classified. So we have completed this step, we have completed this node, and now our current step in state is query classified. So what we do next is we check each of the edges combined like attached to this node and see if they satisfy the condition or not, right? So we go to conditional edge to this node, and after query classify we have these 4 edges. Now for each edge we check if it's satisfied or not. Should continue is our function to see if the where the node, where the graph control will go next. So should continue function, this will determine the next step in the workflow. We get the current step, which is query classified for now, and we get the query type. If the query is classified and type is inquiry or shipping, then go to order handler node. If it's return, then go to return handler, and complaint for complaint handler, right? And if none of these are the case, then just create a generic response and go to the response generator node, right? If you can have several type of query classification here, these are just a few that that will show you how to like create an umbrella over certain queries and then use those to go down in the graph. So these are just same, and if you response generator, then end the query. So for now our query was inquiry. Let's say the first query, the user asks where is my order, and this it will go to order handler. So let's move on to order handler function. This is the order handler function. Basically takes the state, check if order ID, that order for that ID is present or not, get back the response. If error, then give the user a generic response that your order is wrong or order ID is wrong, right? And if it's okay, then get the customer details, save the customer details in the state, then track shipment if available, tracking number or any other information that you want to query, use your database API calls, whatever, and then move to order processed. Now the current step is order processed, and return back the state. That's it. So similar for return handler, you check if the item is eligible for a return or not, if the due date has passed or not, and then make the current step return processed, order processed, and for complaint it's complaint processed. It's a simple code. You can handle these functions however you like. It will just move on to the next stage of the graph. So we have handled these 3 nodes, and now we need to create a response. So these are the edges, conditional edges, and now we have our complaint is done. So now all of those nodes have created these current steps: order processed or return processed or complaint processed. So should continue function will return this as next node, response generator, and we know for response generator we just go to general response node. It's defined here, right? This and this. So what we do is move to generate response, and here we have response generator. So what it's gonna do is take the context that we have stored in the state, whatever information we have collected so far, and then create a response using GPT, warm helpful response that addresses the customer's problems, and if the escalation is required or not. If it's required, then raise it to a operator, actual human customer support. Otherwise just create a response using generic response using GPT and return it back with details of the order, and this will just get the response from LLM. Final response is saved in the state, and current step is saved, and return back the state. So after response, if currently we have just ended the graph from here, but if you want to take any other input from the user, then you can go back to this classify query from general response, add another handler, and the loop can go on as long as you want, right? But I'm ending it now because it's already has gotten quite complex, even just with 5 nodes. And now the final, let's run the final test if our code runs or not. these will be the queries I'm testing. These 5 queries. First is simple, check the status of my order. Second is the return request. Third is disappointed complaint basically, and fourth is tracking your order, and fifth is refund again, right? So I've already run the code here. I'm assuming you have already learned to load the API and initialize the OpenAI object, because this will be using your actual API from GPT. So this will cost you per request few cents per request, nothing huge, right? So we have a test case 1. This is the query that user will ask in your chatbot, and GPT has classified it as order inquiry. Sentiment is neutral. He's not angry. He's not going to register a complaint against you. So priority is medium by default. Order ID he has given. We have got the order ID. Required escalation, no. Resolution steps, and this is actually more complex, so you can handle it, but for now we just move on. So final response, as we have already fetched the details of the user, and we just create the response using GPT and return back that email, right? You have second test case, return the wireless headphones. Same, escalation is not required. Just give the information, all the information you have, to the user, and you, since your order is currently in transit, expected to delivered by this, you can return once you have received the item. So these kind of edge cases GPT can handle itself in the message, but you have to add in manual checks, that too. I'm disappointed with recent purchase, so it's neutral, still neutral. To assist you further, please reach out, blah blah blah. So this is it, guys. You can all you need to do to make it production ready is that you have to handle actual database calls. You have to store the data of the user and their orders, and then you have to define these tools to return back the data. So currently I'm just using as mock test, but these will be real functions that will have to handle checks that LLM can mistake. Like you have to handle the dates and the money, right, money part or currency part. So this is it. Thank you, guys. See you in the next